Concerning waves and the graphs of sine and cosine, we're going to first begin with the property known as amplitude. Abraham Lincoln famously said, although he wasn't the original quote, "Actions speak louder than words." The idea of something being loud is exactly what amplitude is all about. Sound travels in the form of energy waves. Louder louder sound waves are going to go ahead and have a higher amplitude. So essentially what we're saying is that amplitude for a sound wave is also known as volume. So Mr. Lincoln could have stated actions have more amplitude than words. The amplitude, there are actually many amplitudes, but in this case, the one that we're going to be referring to is known as the peak amplitude. It's going to be the absolute value distance from what we call a reference line. In general, it's going to look like this. Imagine, if you will, that you have a graph and it has a maximum point we're going to call m, and it has a minimum point called little m. If we go ahead and subtract those two, take the absolute value, and then half that number, we get the amplitude. To the left, we have a sine graph, and to the right, we have a cosine graph. Notice how similar they look. Let's identify the capital M's, right? The maximums. There's one right here, and that's it for now. So I'm going to pick capital M. There's one. For cosine, you know there's two, one here and one here. Minimums, lowercase m, we have one right here, little m. And over here we have one, little m. Let's draw the amplitudes and label them A. So in this case, the amplitude is going to be from this reference line to the highest point. That's an amplitude. This also happens to be the amplitude right here. You'll notice that in each case, it's a distance, right? If you think this is a number line, if this is going to be your 0, from here to the maximum point is a length of 1. From 0 to the minimum point is going to be a length of 1. So regardless, in this case, the amplitude for this sine graph is going to be 1. Same with the cosine, right? We go from this reference line 0 all the way to the max. That's the length of 1. And if we go from this 0 to this minimum, that is a total absolute value distance of 1 as well.
Most impressive.
Take a moment to summarize. What are some ways to find the amplitude? Problem 2, Desmos. I want you to go ahead and go over to Desmos. So click on this link. It'll take you to Desmos. We're going to go ahead and type in f of x equals a times sine x. It gave me the option to add a slider. I want to add a slider to my meal. Let's go over here to settings, graph settings, and change the steps. I want to type in the word pi. It'll automatically make it into pi. I want to keep it in radians. I'm going to zoom in just to see a little better what's going on. And what I want you to do at this point is I want you to go ahead and answer E, F, G, and H on your own. We'll come back and talk about it in a moment. But I really want to focus and expect you and have faith in you that you'll be able to understand what's going on through self-discovery for E, F, G, and H. I will definitely talk about I with you. So for example, what I'm asking you to do is to go ahead and play with this slider, right? Notice how if this is 1, notice how it's 1 up here, -1 down here, right? Look at the max, look at the min, right? Play with the slider, see what happens with different things go on. Look at the shape of the graph, right? Over here, we had a max right here, and then all of a sudden when I do that, it becomes a min. Interesting. So take a moment to answer E, F, G, and H. So what I'm hoping that you discovered is that as that the positive values of A, right, that's on the slider, they went ahead and made the amplitude larger, okay, and then made it in a positive direction. But when you went ahead and made them small, that number smaller, it gave you a smaller amplitude. The graph was smaller. And then if you went ahead and had negatives, it flipped it upside down. Okay, so negative values are going to flip it. An amplitude of 0 means that you have just a straight line. It's not a sine curve anymore. It's just a straight line from algebra. Okay. In the equation, f of x equals a times sine x, what does a represent? And you'll notice that how does it affect the graph? Well, the only thing that it changed, notice the only thing that it changed, right? You'll notice that regardless of what you did, this point was always here in 0, this point was always here in 0, this was always hitting 0. So no matter what I did with this slider, it didn't change anything else about this graph except for the fact that, just like a jump rope, right? Is that it went ahead and changed the amplitude. That's all it did. Okay, here's an inverted, here's the right side up. Okay, the only thing that the amplitude changed was, sorry, the only thing that the A and the amplitude changed was the height of the graph. Problem 3, let's go ahead and create some equations for these graphs. So these are sine. Let's start off with the blue one. The blue one looks like it has an amplitude of 1. From here to here is 1, 1. It's going to be 1 times sine of x. Now, we don't have to even have the 1 there. You can if you want. It's a good habit. But if there isn't a 1 or a number here, that means that it is 1. For the red one, however, you'll notice that it's also sine, right? The same shape, but it has an amplitude of 2 this time. And it's the right side up, so it's going to be a positive 2. Take a moment to summarize. For either a sine or a cosine graph, where can the amplitude be found in the equation of the graph? Give the amplitudes for the following graphs. Now, you don't have to go mathematical, you don't need to, but you can if you want to. So let me show you how we would use that little equation that we showed you earlier, right? Amplitude is 1/2 max minus min. So if I look at A, for example, you'll notice that my max is going to be at 2 because this is going up by 2s, and my min looks like it's -4. So my max is 2, my min is -4. That's 1/2 2 minus -4.
That's all there is to it.
The amplitude is 3. What if you don't know what your max and min is, or what if you went ahead and just mix them around? Well, it'll still work out because if you do the signs right? This is an algebra 1 pre-algebra problem. So the amplitude for this graph is 3, meaning that if I were to theoretically draw the line of reference, it would be down the middle right here. And what I propose to you is that from here to here would be 3, and from here to here would be 3. We don't have to even do any math if you don't want to. You'll notice that it goes 2 up this way, 2 down this way. This is nice because it actually has a reference line down the middle, cuts in half perfectly. So the amplitude of this one is going to be 2. You could also do the formula. You'll notice that it works as well. Okay, you'd have a max of +2, a min of -2, and it would go ahead and work out likewise. Looking at C, however, this is interesting. You'll notice that this right here is -2, so that's a -1. That's a 1, and that's a 2. So the max is at a 2. It has many maximums. Kind of looks like this in time for Halloween, right? Looks like I don't know, Batman or a bat or something. A max at 2. The min is at 0. These are all hitting the 0 at the x-axis. That's 1/2 2 minus 0. It's 1/2 2, and half of 2 is going to be just 1. So the amplitude is 1. If we were to go ahead and want to draw a reference line for this, it'd be going down this way. So then there's 1 going up, 1 going down. Problem 5, understanding. Give an equation for a cosine graph with an amplitude of 2. We know the amplitude goes in front, and it's going to be a cosine graph. And that's it. Part B, give an equation of a sine graph that has been inverted. So what would I put in front of this to invert it? If you look back to the Desmos problem that you did, what kind of numbers flipped the graph upside down? -1 isn't the only option. Remember, I'm asking for give an equation, not the equation. However, you would be, this is an example, right? You could put -4 if you want. You could put -3. You could put -14. The idea is that whatever you have, it has to be negative. A negative number in front of the sine or the cosine will invert. It will flip the equation upside down. So essentially, this, for example, is a positive sine graph. This is a negative sine graph. Okay, flips it upside down. What about for a cosine? Cosine, negative cosine. It just flips it upside down. We can do this a couple of ways. If you want to just go ahead and do a quick little simple, here's 1, 2, 3, 4, 5. Here's 5. Here's the middle. Here's sine. So graphically looking at this, the amplitude is going to be 2, up and down. If you're not comfortable with that, you can do the math. Right? The max is 5, the min is 1. Remember, these are absolute values, not 15s. Half of 4 is 2. The 2 goes in front because the amplitude goes in front. There's sine. D, graph this. labeling the y-axis only. So you'll notice that the amplitude is 2. I'm going to go up to 1, 2. But I'm also going to go down to -2. And don't worry about the x values right now. You just know that in general, this is going to look like this, right? We'll worry about these x points in the future. E, I want you to graph this again, but this time I want you to make it negative. So if we make it negative, it'll be like this. Sometimes it helps to draw the original and then draw the flip and then erase it. Graph 1/2 sine x. But Mr. Over, I can't do fractions even though I'm taking a college class. I know, it's okay. So, whoop-de-doo. I'm going to draw that. I'm going to call it 1/2. I'm going to call it negative 1/2. I'm going to draw the sign. The end. That was it. That was it. Summary. Does a negative technically affect the amplitude? Does it affect the graph? Explain.